Okay, we're going to look at a program that provides a loan amortization table for some credit union. A loan amortization table is a table that tells you on a month-to-month basis how much you're paying in interest, how much you're paying towards the principal, and how much your total payments are for a loan, and also what the remaining principal is. So we're going to look at some of the things that we've learned so far and maybe look at some things that could be used to improve it. There is a problem with the zero interest loan and we'll get into that. But first let's look at the program over here. Over here the I/O manip library, the input-output manipulation library, we need that so we can properly format dollar amounts with 2 decimals, for instance. We can also use it to left align and right align columns, basically make the output look better. And we have to include the CMath function over here because for the formulas to calculate the monthly payment, we're going to be using the power function, and that's included in the CMath library. Good. Now, the number of payments is definitely a whole number because we pay for a number of months. And each month is countable, 1 month, 2 months, 3 months, etc. All the other numbers are appropriately expressed as doubles. The loan amount, it could be like 130,000 and then 56 cents. The interest rate has to be a double. Because we need to be able to use decimals. Now you could think that an interest rate is 4, but you might also have a 4.38% interest rate. And let's also remember that we don't have anything like a percent sign in C++ that actually acts as a percent. What we actually should be doing over here, 4.38% is 0.438. So that's how we would be using that in our program. The monthly interest rate, same thing. Now, in order to get the monthly interest rate, what we simply do is take the annual rate and divide it by 12. That's how the whole system is set up. Years of the loan, you might think, okay, we can use an integer there, but there may be times when you say, you know, I want to have a loan for 12.5 years. And that should be possible too. The balance, if we start with this amount over here, and we make a payment, we'll probably end up with another number with decimals. So the balance needs to be a double 2. The term is one of those formula things that we'll be using. We use that to calculate the payment, and the actual payment each month is declared as payment. Okay. So we need to get some information from the user, and we want first to know the loan amount. Now we cannot have a negative loan, so it has to be a positive loan, and you see over here that there is an input checking, and the input checking says if it's less than or equal to 0, then we ask for it again. And over here it says enter a loan amount of 0 or more. And I think we can agree that's kind of contradictory. So let's mark this with a bunch of question marks and see what happens when we correct this. Then an interest rate, and you give good instructions to the user. You make sure that they know that it's going to be as a fraction instead of a whole number and then the percent sign. So there's appropriate input, otherwise you might get a loan for 500% as opposed to 5% by accident. We cannot have any negative rates, so over here they say please enter a positive rate or zero, and as I have indicated before, there may be a problem when we actually try to apply a 0% rate. Then the years of the loan. The loan is going to be running over here from 1 to 30 years. If it's less than 1 year, then we have to enter the years again. If it's more than 30, then we have to ask for it again. But 1 and 30 should be appropriate numbers. So this is where we get past the input checking, and then we're going to be using the actual calculations. So what we really want to do is calculate the monthly payment, and we do that in a couple of steps. First we want to have the number of payments, and we have a number of years. In each year we have 12 months. And we want to make sure that the number of payments is going to be an integer. So what we actually use is a static cast to an integer over here for the years times 12 months in a year. Then we have to create the monthly interest rate. Now over here rate is already a double. So the fact that it's listed over here is divided by 12.0 is not really necessary. You could just divide by 12, because if you divide a double by an integer, 12, then you still get a double, and the monthly interest rate is a double too. This is kind of some extra security. It's probably a good habit to get into if you're ever in doubt whether you're going to be working with integer division or multiplying integers, and you want not to have an integer but you want to have a double. You know, just divide by something with a decimal. 0.0 qualifies, or multiply it with a number that has the 0.0, and that's automatically going to create the result as a double then. This over here we're not going to explain. Do see that a term over here is used as a variable in the calculation of the payment, so it's kind of an intermediate step. We're not going to worry about this. The 1.0 over here again is to make sure that you're not going to be working with integers here as a result. Okay, now over here we're going to use fixed show point and set precision of 2. So from this point on, all numbers are going to be expressed as numbers with 2 decimals, except for the integers, of course. And over here we show the user the monthly payment, and then we're going to create the actual report. This over here just creates an extra line, give it a little bit extra space, and then over here we have the header, and we create columns over here and we use the set width, and you can use the same width for the actual calculations a little bit later on too. Okay, now we're going to keep track of how much of the loan still has to be repaid. So initially we set the balance at the value of the loan, and then as we make payment, the loan itself will stay the same, but the balance is going to decrease as we make payments towards the balance, the principal. Okay, and now over here we're going to create for each month the amounts. So we start at month number 1. We have calculated the number of payments as the number of years times 12, and we do it for each and every month, so it's probably going to be a little bit long, but we'll just scroll through the output. Over here we need to define the monthly interest and the principal. We don't have those yet. And then we're going to calculate the amount paid for this month, interest and principal. The monthly interest is the monthly interest rate times the balance. And then since the payment is a little bit larger than that monthly interest payment, the remainder is going to go towards the principal. Over here, if the month is not equal to the non-payments, then we're going to deduct the payment minus the monthly interest and get the remaining principals. If we are at the end over here, of course, you're not going to make an extra payment, and you'll see that at the end of the table too. Otherwise, if we are at the end over here, then the principal is equal to the balance, and the payment is going to be calculated as the balance plus the monthly interest. So this is for the last month only. And then over here we're going to calculate the new balance loan. The balance is the same as the balance without the principal payment. And then over here you see for each line the set width with the month, the interest, the principal and the balance. So let's clear this. And we're going to run this program, and we're just going to use some correct values, and we'll take 100,000 and I'll just add 50 cents to it just because we can. The annual interest rate 0.05 looks like a good one, and in the years of the loan I'll take it 12.5 years, again just because we can. And then over here we have created the table, and you see that it's quite long. Okay, and if you would add this balance over here and the principal payment, the payments toward the principal, then you would get over here the loan amount. Likewise, if you add over here the balance and then the payment towards the principal over here, then you would get this balance here. This is how much is going to go to the interest. So you see that on a $100,000 loan with 5% interest, you're paying per month more than $400. But over time that's going to be decreasing until finally you have just a tiny little bit left over here, and that's going to be paid over here, and your loan is going to be totally paid off. Likewise, if you look at the principal amount, the payment towards the principal, starts relatively low over here, and then it starts going up, starts at 481, and then towards the end we have a payment of 897, and in the beginning only a little bit more than 400 is going towards the principal, so you're paying quite a bit of interest. But you see that each month you're paying more on the principal. It goes from 481 up to almost that whole payment amount, in this case 894, compared with the 897 of the total payment. And over time you see that your total balance goes down. Over here it's 99,000 and keeps going down, and then finally you have everything paid off. Okay, so this is a typical scenario. Now let's run another scenario, and I've told you that there was a problem with zero interest loans. So we're going to take the same loan amount, and we're going to say that there is a zero interest, and then we'll take the same 12.5 years for the loan. And what we see over here is just somehow, you know, it's NaN, every amount, and this is basically not a number, and that's an indication that it's outside of the range of a double. It's either too small or way too large, and it just doesn't fit. So a zero interest loan is not going to work too well. Let's look at another scenario over here. And this time we're going to make a mistake with the interest. So 100, 1000, 50, and somehow we don't take into account that it should be expressed as a fraction. We just do it as a whole number. So we put 5 over here, and the years of the loan 12.5, and let's see what that does. So of course this doesn't make much sense. So you have $100,000 loan, and you run it for 12.5 years. Each month you pay more than 41,000 to the loan, and if you look at the balance over here, you see that the balance never decreases. And all of a sudden, magically, you make one big payment towards the principal and your loan is totally paid off. I'd hate to have that type of loan. Okay, and then finally let's look at what we can do with the years. And we take the same loan amount again, and the annual interest rate will take the 0.05 again, and this time the years of the loan. Let's see what happens when we do less than a year. 0.5 years, and that's something I cannot do. If I want to have a 40-year loan, that's not going to be possible. Let's see if 30 years is still accepted. and it looks that it is 30 years, 12 months, 360, so that looks like it works just well. But we do have a couple of small problems that we need to focus on.